How do bone marrow transplants create human chimerism? Imagine a person's body becoming a mosaic of two different sets of genetic material. That's what happens when a bone marrow transplant creates human chimerism. It might sound like science fiction, but it's a real medical process with important ethical questions. When doctors perform a bone marrow transplant, they introduce healthy donor stem cells into a patient whose own marrow has been damaged or destroyed by disease or treatment. These donor stem cells settle into the patient's bone marrow, where they begin to grow and produce new blood and immune cells. Because these cells come from the donor, they carry the donor's DNA, not the patient's. Over time, the patient's blood becomes a mix of their original cells and the new donor cells. This mixture is called chimerism, named after the mythological creature made of different animals. There are different types of chimerism. Complete chimerism means all blood cells are from the donor, fully replacing the patient's original cells. Mixed chimerism is when both donor and patient cells coexist, with varying amounts. Microchimerism is when only a tiny percentage of donor cells are present, less than 1%. The process starts with conditioning the patient, often using chemotherapy or radiation, to wipe out or suppress their own marrow. This creates space for the donor cells to take hold. After the transplant, the donor stem cells migrate to the bone marrow niches and begin producing new blood cells. Over weeks or months, the patient's immune system and blood system become a mosaic of both their own and the donor cells. This chimeric state is essential for the success of the transplant, especially when treating blood disorders like sickle cell disease or immune deficiencies. The donor immune cells can help restore immune function or fight off disease. Doctors monitor the level of donor chimerism to see how well the transplant is working and to guide ongoing treatment. From an ethical standpoint, creating human chimerism through bone marrow transplants raises important questions. Patients must be fully informed about the nature of chimerism, understanding that their body will contain genetically distinct cells. Consent is vital, and they need to know about possible risks like graft versus host disease, where donor immune cells attack the patient's tissues, or long-term immunosuppression. Ensuring fair access to these treatments is also a key ethical concern, so everyone who needs a transplant can benefit. Patients have the right to accept or refuse the procedure after understanding its biological and ethical implications. In essence, bone marrow transplants create human chimerism by allowing donor stem cells to engraft and produce blood and immune cells within the recipient. This process can save lives and treat serious diseases, but it also prompts us to consider the ethical aspects of altering human biology and the importance of respecting patient autonomy and fairness.